This is a series of multiple choice questions for AQA A-level chemistry on the topic amount of substance. This is the second set of questions. I'm going to recommend that you pause on each question, have a go at answering it, and then see how you do by progressing through the video. So let's start with number one. And on here, we're looking at the amount of sodium hydroxide that would react exactly with 7.5 grams of a diprotic acid, H2A, for which we're given the MR. So there's a lot to unpack here. Let's start with the equation. We know that if we have a monobasic alkali and a diprotic acid, then when we balance it, we're going to need 2 moles of the NaOH to go with 1 mole of the H2A. Think of this as being the A is SO4. So we're doing a sodium hydroxide sulfuric acid calculation or titration. And with that balancing, we can then start to move forward. So that 2-to-1 ratio is really very important. What I'm then going to recommend you do, and I would always do this if you're ever given a mass of something and you have its MR or you can find its MR, find the number of moles. So in this case, we've got a mass of H2A and an MR. So let's find out how many moles it is. 7.5 divided by 150 gives 0.05 moles. So 0.05 moles, and we know that 1 mole of H2A reacts with 2 moles of NaOH. So we now know that we started with double that 0.05. We had 0.1 moles of NaOH. And if we know that, we can then start to work through these calculations. And in the first instance, I'm now going to see that if I've got my number of moles calculated as concentration multiplied by volume, in A, that would give me 0.0025 moles of NaOH. Well, that's not correct. It's 0.1. On the second example, I've got my concentration is 0.5 and my volume is 0.1. You can see in both of these I've converted my cm cubed to dm cubed. That gives me 0.05 moles. So again, that's incorrect. If I take 100 cm cubed of 1 molar NaOH, well, my concentration is 1 and my volume is 100 divided by 1000, which comes to 0.1. So I found the correct answer. We're looking for C. On to the second question of 5 here. Have a look through this one. And in this, you need to look at the state symbols. We're making solid lead iodide. It's a common precipitation reaction. And again, you've been provided with some information. We've got concentration and volume of each of the 2 compounds. So let's work out how many moles of each of them we started with. Well, N is C times V. Concentration is 0.1 and my volume is 25, but divided by 1000 because I want it in decimeters cubed. Now this means I started with 0.0025 moles of lead nitrate and 0.0025 moles of potassium iodide based on the information given in the question. Now from there, I can see that if 1 mole of lead nitrate reacts with 2 moles of potassium iodide and I have 0.0025 of each, I'm going to run out of my potassium iodide first. That becomes my limiting reagent. And if that's my limiting reagent, I can use the mole ratio of Ki to lead iodide, which is 2-to-1, to find out how many moles of lead iodide I would have ended up with. And on that basis, I'm going to end up with 0.00125 moles. That's half the amount of Ki that I started with. Now that tells me that the correct answer is A. The correct amount in moles of lead iodide. Next question, have a go at this one. Relatively straightforward on here. We've been given a mass of nitrogen, and if you've got the mass, you can always find the MR. You've got to remember that nitrogen is diatomic. So 6 divided by 28 gives me 0.214 moles of nitrogen. Now, from there, I can find the molecules of nitrogen. So N2, that's going to be 0.214 moles multiplied by Avogadro's number, 6.022 by 10 to the power of 23. And that is going to take me to 12.887 by 10 to the power of 22 molecules of N2. We have another consideration to take into account here, and that is that within each N atom, there are 7 protons. So within an N2 molecule, there are 14 protons. So we are going to take that figure, the number of molecules, and we are going to multiply it by 14. And that takes us to an answer of 1.8 by 10 to the 24. The correct answer is C. Let's move on to the next question. And again, there's a lot to take on board here. We started with 30 centimetre cubed of nitrogen, 60 centimetre cubed of fluorine. Now, these are gases, and we know that at a fixed temperature and pressure, so standard temperature and pressure, we would have a fixed volume. The volume is proportional to the number of moles. So, I have got 30 centimetre cubed of nitrogen. And at the beginning, I've got 60 centimetre cubed of fluorine and 0 centimetre cubed of nitrogen fluoride. I know from the 1/2 to 1.5 or 1:3 ratio that my limiting reagent is F2. 60 cm cubed of it will react by reacting with 20 centimetre cubed of the nitrogen. Now that means 10 centimetre cubed of the nitrogen remains unreacted. I also know from my mole ratio, my 3:2 to my 1.5 to 1 ratio, that 60 cm cubed of the fluorine that has reacted will make 40 centimetre cubed of NF3. So I know that I've got 40 centimetre cubed of NF3 that I've made, and I know that I have 10 centimetre cubed of the nitrogen left over. I add those together, and that gives me a total volume of 50 centimetre cubed. Really a quite difficult question there. Next question for you to try. And again, on this one, we've got what? We have a volume, we have a mass. Now, I'm going to say work out the moles, because if we're given a mass, we know the formula of ammonia is NH3. So we can work out its molecular mass is 17. N is 150 over 17, which is 8.82 moles. Now, you can see that that's an answer here. They're banking on some people missing the fact that there's another step, because I now need to work out the concentration, and I do that by taking my number of moles, 8.82, and dividing by my volume. My volume is given in cm cubed, but because concentration is in moles per decimetre cubed, I'm always going to do that conversion. So 8.82 over 0.5 gives me a final answer of 17.6. The correct answer is D. And that takes us to the end of this video. Thank you for listening, and goodbye.